Dear students, now we will solve two problems related to the nth term of sequences. So here on the board I have two problems now. If an is equal to n square plus 1, find first three terms of sequence. So what is the meaning of this question is, some sequence is there. For that sequence they have found out its nth term and it has been given to us that using this nth term of that sequence, find the terms of the sequence, that is first three terms of the sequence. So usually they ask only for first three terms of the sequence, because to define any sequence we need just three terms of the sequence, that is first three terms of the sequence. Right. So let us solve this. Let us find the first three terms of the sequence. Now take the nth term. An is equal to n square plus 1. So n is raised to the power 2. So in order to find out the first term, we have to put n is equal to 2. So what we had discussed in yesterday's class. So put n is equal to 1. So an, that is a1. Put n is equal to 1, that becomes first term, so that is 1 square plus 1. So a1 is equal to 1 square is 1 plus 1, so a1 is 2. So what is the first term of the sequence? The first term of the sequence is 2. Let us find out the second term. Write down the nth term of the sequence. An is equal to n square plus 1. Put n is equal to 2. So a2 is equal to, in place of n I substitute 2. So 2 square plus 1. So a2 is equal to 2 square is 4 plus 1 and a2 is 5. So the second term of the sequence is 5. Let us find out the third term. Again write down the nth term, that is an is equal to n square plus 1. So put n is equal to 3 in order to find out the third term. So a3 is equal to 3 square plus 1. a3 is equal to 3 square is 9. 9 plus 1. So therefore a3 is 10. So the first three terms of the sequence are 2, 5 and 10. So this is the method of finding out the terms of the sequence by using the nth term of the sequence. Let us go with the second problem. It is the same problem. Nth term is different. If n is equal to minus 1 whole to the power n into 2n, find first three terms of the sequence. So it's the nth term of the sequence. The same method follows, no changes. Just the nth term has been changed. It's a different sequence. It's a different sequence. So n is equal to minus 1 whole to the power n into 2n. So minus 1 is a negative number which is raised to the power n. Here n is a natural number. So any negative number raised even number of times will be a positive number, and if a negative integer is raised odd number of times, then it becomes an odd number. That is, odd number of times it becomes a negative number. So let's go with this. Put n is equal to 1 in order to find out the first term. So a1 is equal to minus 1 whole to the power 1 into 2 into, again in the place of n we are going to substitute 1. Clear? a1 is equal to minus 1 whole to the power 1 is minus 1 raised to the power 1. So it is minus 1 itself into 2 into 1 is 2. So a1 is equal to minus 1 into 2 is minus 2. So the first term of the sequence is minus 2. So in order to find out the second term, write down the nth term. An is equal to minus 1 whole to the power n into 2n. So put n is equal to 2. So this becomes a2 is equal to minus 1 whole to the power 2. So a negative number raised 2 times. That is minus 1 into minus 1. So that becomes minus into minus is plus, 1 into 1 is 1 into 2 into 1 is, again in the place of n I am going to substitute 2. So a2 is equal to minus 1 whole square is 1 into 2 2s are 4. 1 into 4 is a2 is 4. So the second term of the sequence is 4. Now let us find out the third term. So write down the nth term again, minus 1 whole to the power n into 2n. So in order to find out the third term of the sequence, you have to substitute n by 3. So put n is equal to 3. So a3 is equal to minus 1 whole to the power 3 into 2 into 3. So a3 is equal to minus 1 whole to the power 3 is the negative number raised odd number of times. Any negative number raised odd number of times remains negative. So it is minus 1 into 2 3s are 6. A3 is equal to minus 1 into 6 is minus 6. So the first 3 terms of the sequence we have got. So that is minus 2. Second term is 4. And the third term is minus 6. So these are the first 3 terms of the sequence. Hello everyone, welcome back to SP Gubi online classes for mathematics and science for SSLC and CBSE. So yesterday we had discussed regarding what is a sequence, types of sequences, and we solved very simple problems on sequences. So today we are going to recapitulate everything what it was done yesterday, and then we will go with the further more problems on sequences. Okay, we'll come back. So let us recapitulate what is a sequence. So a sequence is an orderly arrangement of numbers according to a given rule. So there are infinite number of rules which can be made, and therefore there are infinite sequences. So according to this, we have two types of sequences. One is finite sequence, another one is infinite sequence. So what is finite sequence? A sequence having finite number of terms are called as finite sequences, and the general form of a finite sequence is a1, comma a2, a3, a4, an. So in a finite sequence you will be having the nth term, that is the last term. So in what is an infinite sequence? A sequence having infinite number of terms is called as an infinite sequence, and the general form of an infinite sequence is a1, a2, a3, a4, So here infinite sequence do not have an nth term. That is the difference between a finite sequence and an infinite sequence. So next coming to sequences. A sequence can be represented in two ways, as I told you yesterday in yesterday's class. A sequence can be represented by using its nth term, and also a sequence can be indicated or shown by using or writing the terms of the sequence itself. So based on these two concepts, we are going to do or solve problems on interconversion. Interconversion in the sense, when the nth term of a sequence is given, we are going to learn how to get the terms of the sequence, and if the terms are given in a sequence, then how to find its nth term, and some more related problems on sequences. So now, in order to solve further problems on sequences, we have to get a small knowledge regarding the general form of a sequence, which we had discussed in the previous class. So here, general form of a sequence can be written like this: a1, comma a2, comma a3, comma a4, continues. So looking at this, you might tell me that it is a general form of an infinite sequence. If I write the nth term, that is an for the given sequence, then it is going to become a finite sequence. Now, we know this is the general form of a finite sequence, we know this. So now, if I want to get in this sequence, in this finite sequence, if I want to get the next term of the sequence, how it can be written, how it can be guessed. So here, according to a particular rule, usually a sequence is written according to a particular rule, and it will be in an order. Okay, let us consider this. It is already in an order, and according to some rule it has been written. Therefore, it is called as a sequence. So now we have the nth term. What will be the general form of a term next to the nth term? So this is the last term. This is the nth term. What will be the next term? How to write the next term? Right. So after the third term you get fourth term. After the second term you get the third term. Similarly, after the nth term you are going to get a term more than the nth term that can be written as an plus 1. So can you guess the next term of an plus 1? Yes, you are right. An plus 2. Can you guess the next term of this an plus 2? An plus 3. And this goes on. Now, a very important thinking part of this sequence comes now. I hope you will answer this. The preceding term of A4 is A3. The preceding term of A3 is A2. So 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. It's going on like in that pattern. Can you guess the preceding term of the nth term? Preceding term. So it may look like n minus 1. 1 less than the nth term is represented by n minus 1. Can you represent the preceding term of n minus 1? So that will look like an minus 2 and so on. So if this is the nth term, the preceding term will be an minus 1, its preceding term will be an minus 2. If this is the nth term, then the succeeding term, the term next to that is called succeeding term. The succeeding term of nth term is an plus 1. The succeeding term of an plus 1 is an plus 2. The succeeding term of an plus 2 is an plus 3. It goes on like this. So you should get the idea of this. You should be having the idea of the general form of this type of sequence for solving some type of problems on sequences. So based on the general form of nth term of a sequence, we are going to solve two very beautiful problems on that. So let us go with the problem. If an is equal to 4n plus 1 is the nth term of some sequence, we do not know that sequence. An is equal to 4n plus 1. Find n plus 1. So can you remember where n plus 1 comes? So it is the succeeding term of the nth term, isn't it? Next is find n minus 2. So it is the preceding term of n minus 1, and n minus 1 is the preceding term of an, isn't it? When you look at the general form of a sequence, you will come across this. So let us find out an plus 1 and an minus 2 using an is equal to 4n plus 1. So in general, in a sequence, if the nth term is represented as 4n plus 1, how an plus 1 is represented generally and an minus 2 is represented generally. So that is the base of the question. Right. So let us go with the solution. Write down the nth term. An is equal to 4n plus 1. So put n is equal to, in order to find out an plus 1, substitute an plus 1 in place of n. That is, put n is equal to n plus 1. That's all. So n plus 1 is equal to 4 into, substitute n plus 1 in the place of n. So as it is a binomial, we have to put it inside brackets, n plus 1 plus 1. So an plus 1 is equal to 4 into n, that becomes 4n. 4 into plus 1 is plus 4 plus the 1 carries. So an plus 1 is equal to 4n plus, add the constants, that is 5. So what is an plus 1? That is 4n plus 5. Let us go with the second problem. So an is equal to 4n plus 1. So put n is equal to an minus 2. That is n is equal to n minus 2. So in the place of n we have to substitute n minus 2 in order to find out an minus 2. So n minus 2 is equal to 4 into n is n minus 2 and plus 1. An minus 2 is equal to 4 into n is 4n. 4 into minus 2 is minus 8 plus 1. So an minus 2 is 4n. So here there are two constants with different signs. So that is minus 8 plus 1. So minus 8 plus 1 becomes minus 7. So what is the general form of an minus 2 is 4n minus 7. So generally, if this is the sequence a1, comma, a2, comma, a3, comma, dot, 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 and this is an, this will be an minus 1, and this will be an minus 2, and this will be n plus n minus 1. Sorry, n plus 1, this is n plus 2, this is n minus 1. So if an is represented by 4n plus 1, then an plus 1 looks like 4n plus 5, and an minus 2 that comes here, an minus 2, and that looks like 4n minus 7. So this is how the problem is designed. Now we will go with a very classical problem in sequences, very important, maybe asked in your exams. In a sequence, if an is equal to 4n square minus 1, find n. If an is 35. So in the sense, how we should understand this sequence. For example, we have a sequence where a1, a2, a3, a4, a5, dot, 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 an is written. Nth term is 35. This is the first term. This is the first term here. This is the nth term. Nth term is 35. So in this problem we have to find out if the nth term of the sequence is 4n square minus 1 and if nth term is 35. So these two are equal. 35 is equal to 4n square minus 1 because 35 is the nth term. 4n square is the general form of the sequence. So therefore 4n square minus 1 is equal to 35 because 35 is the nth term of the sequence and an is 4n square minus 1. We can take 4n square minus 1 is equal to 35. So starting from the first term until 35, in that sequence, how many terms are there, or we are finding out in that sequence which term is 35. It is the last term, no doubt in that. 35 is the last term of that sequence, no doubt in that, but which term? We have to give a number. There are many students in the class. If I go on taking the roll numbers, the last boy is the nth term, no doubt. But he is, as there are 100 students in the class, therefore that last boy is the 100th boy. Something like that. So in this sequence, we are having, that is an is equal to 4n square minus 1 is given, and nth term is 35. So nth term is the last term. So in order to find out, we are finding n in the sense it gives two meanings. One is from the first term of the sequence until 35, how many terms are there? That is one of the way of understanding to find out n. And the other way of understanding to find out n is 35 is which term of the sequence. Which term of the sequence. So that is n. So n is always here, we have to remember that it is always a natural number. If you are going to get n as some negative values when solving problems, or when you get a negative value for n at the solution, somewhere you are wrong because n is always a natural number. So let us take the term. So an is equal to 4n square minus 1. So in place of nth term is 35. In that sequence, 35 is the last term. So therefore, in place of nth term, I am going to substitute 35 and that becomes 35 is equal to 4n square minus 1. I start doing the algebraic process here. So minus 1 will be transposed to the LHS. So that becomes 35 plus 1 is equal to 4n square. 35 plus 1 is 36 is equal to 4n square. When you interchange the LHS and RHS, no question of changing the signs. So n square is equal to take out 4 and place it below 36. Divide by 4. 4 ones are 4. 9 side is 36. N square is equal to 9. So when you take square root of both sides, it becomes square root of n square is equal to plus or minus square root of 9. Square and root cancels. N is equal to plus or minus 3. So which value you are going to take? Will you take plus 3 or are you going to take minus 3? We have to take plus 3 because n is always a natural number. So therefore, since n is natural number, so therefore n is equal to 3. So what is the in this sequence, which term is 35? It is the third term. So in this sequence, how many terms are there? Until 35, there are 3 terms. Because 35 is the third term, therefore in this sequence there are 3 terms. Right? I hope you understood. Right. So after sequences, we are in an advanced stage of sequences, that is, we call it as series. A very important concept which is also continued in your arithmetic progressions. In further of the chapter we get arithmetic progressions. There also we get come across series. So in sequence also we have series. So let us take the general form of a sequence and let us see how it becomes a series. How a sequence becomes a series. That's very simple. So here A1, A2, A3, A4, A is a sequence. It's the general form of a sequence. At times, we need to add the terms of the sequence. At some situations, at times, we need to add the terms of the sequence. If you are adding each and every term of a sequence until required, then that sequence becomes the series of the corresponding sequence. Very simple. How to convert this into series? A1 plus A2 plus A3 plus A4 plus plus. So this becomes a series of this sequence, right? Okay. Now this is a finite sequence because it has the term, right? Starting from the first term, you have added all the terms in the sequence. Therefore, as it is a finite sequence and the terms of this finite sequence are added, therefore this is the series of the finite sequence called as a finite series. And in the finite series, as you are going to take that sum of terms from first term to nth term, and nth term is represented by an. The sequence has n terms, so therefore you have taken the sum of 2 n terms. Therefore, a series is represented by Sn. So it is written as sum of 2 n terms. Very simple. Sum of 2 n terms. So what is a series? Very simple. If the terms of a sequence are added, then it is called the series of the corresponding sequence. So this is the series of a corresponding sequence which is represented by Sn. Sn represents sum of 2 n terms. Now, I will take Sn, sum of the n terms. I will put n is equal to 1. I will substitute n is equal to 1. So that becomes S1. So what does this mean? S1, what does it mean? S1 means sum up to the first term. In a sense, first term itself. So S1 is A1 itself. S1 is A1 itself. Now, if I put n is equal to 2, that becomes S2. S2 in the sense, sum of two terms of the sequence. So sum of the two terms includes the first two terms of the sequence, that is A1 plus A2. So what is S2? It is A1 plus A2. So if you put n is equal to 3, sum of the three terms is taken. It is taken that sum of first three terms of the sequence. First three terms of the sequence, not third, fourth and fifth, not 7, 8 and 9, not like that. Sum of the three terms means the first sum of first three terms of the sequence. So that becomes A1 plus A2 plus A3. So if you take similarly S4, it is the sum of first four terms of the sequence. So that comes A1 plus A2 plus A3 plus A4. This is the first four terms of the sequence. Similarly, S5 is A1 plus A2 plus A3 plus A4 plus A5. So similarly, you can guess S6. Simultaneously, you can go with the S7, S8, S9, S10, something like that. So I have a very interesting question for you. Now, if I take some of the n terms, and I take some of the n minus 1 terms of a same sequence. Consider that we have a sequence. I am going to take the sum of the first 8 terms, that is from the first term to last term I take the sum, I get Sn. From the first term to n minus 1 terms I take the sum. Sum of the n minus 1 terms means what? Last term minus preceding term. The term which is behind the last term is n minus 1. So if you take sum of the n minus 1 terms, I take here, I subtract sum of the n terms minus sum of the n minus 1 terms. So can you guess what I get? Okay, sum of the n terms I will take. Sn is equal to A1 plus A2 plus A3 plus dot 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 an minus 1 plus an. This is the sum of first 8 terms. Now we take sum of the n minus 1 terms. A1 plus A2 plus A3 plus dot 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 dot. Sum of two n minus 1 terms. I take the sum. That becomes Sn minus 1. I subtract. So this sign changes for all the terms. So A1 cancels, A2 cancels, A3 cancels, An minus 1 cancels. So what is the left out thing? What is the thing left out? Therefore Sn minus 1 is equal to what? An. So this is the result. So what is Sn minus 1 is the last term of that sequence. So based on series, we will solve a very simple problem related to the series of a sequence. So problem goes like this. In a series, so you have to understand what is a series, you have to remember what is a series here. Sum of the terms of the sequence is called as the series of the corresponding sequence. So in a series, if the nth term is represented by 3n plus 1, then find S3. S3 in the sense, you have to find out first 3 terms of that sequence. So in order to find out S3, we need the first 3 terms of the sequence itself. Without knowing the terms of the sequence, we cannot find out the sum of the terms of the sequence. So to find out the first 3 terms of that sequence, we are going to take the help of the nth term of the sequence. So take the nth term. A is equal to 3n plus 1. In order to find out the first term, what is to be done? We have to substitute n is equal to 1. So put n is equal to 1. So a1 is equal to 3 into 1 plus 1. a1 is 3 into 1 is 3 plus 1. That is 4. a1 is 4. So in order to find out the second term, a is equal to 3n plus 1. Put n is equal to 2. So a2 is equal to 3 into 2. In place of n, I am substituting 2 plus 1. So a2 is equal to 3 2s are 6 plus 1. That is 7. I will go to the process of finding out the third term. a is equal to 3n plus 1. Put n is equal to 3 in order to find out the third term. So a3 is equal to 3 into 3 plus 1. a3 is equal to 3 3s are 9 plus 1. That comes to 10. So a3 is 10. So now we have the first 3 terms of the sequence. Using this, just we have to find out S3. I hope it's enough. S3 can be written as a1 plus a2 plus a3. So S3 is a1 is 4 and a2 is 7 and a3 is 10. So S3 is equal to comes to 21. 10 plus 7, 17, 17 plus 4, 21. So what is S3? That is 21. So here we come to the conclusion part of sequences and the related series along with that. So from tomorrow's class we will be going with the chapter itself. Officially I am entering into your syllabus. So this was the basic required before entering into arithmetic progressions. I hope you have enjoyed the basics. From tomorrow in tomorrow's class I will be teaching you what is an AP, the nth term of an AP and related concepts with that. So the notes regarding this class will be sent to you through the WhatsApp. So be in the WhatsApp group. So subscribe to the channel. I hope you enjoyed this sequence and problems on series. Right. Wish you a happy learning. See you with arithmetic progressions. Thank you very much.